We want to graph this hyperbola and determine the center, the vertices, and the equation for the asymptotes. So first, quick review as to why it is a hyperbola. Remember, because of the subtraction, that's our key indicator that we have a hyperbola, as well as the fact that both x and y are squared. So subtraction and both x and y are squared. Then remember, on hyperbolas in this form, our a squared value is always going to be first. So in this case, a squared is equal to 4, which means a is equal to 2. And you'll also notice that y is first, and because y is first, that tells us that we are looking at a vertical hyperbola. This will be one that has a vertical transverse axis. All right, so now let's move on to the center. So we'll take a look at the x squared and the y squared, and if you'll notice, there's no values that are added or subtracted to the x and to the y. So that tells us that our hyperbola has not been shifted, and it has a center at 0, 0. So we can begin generating our graph. So since it's a vertical hyperbola, center's at 0, 0, and a is equal to 2. Remember, a is the distance that we will travel to get to the vertices. And because it's vertical, we'll be traveling up a distance of 2 and down a distance of 2 from the origin to get to our vertices. So the coordinates for your vertices will be 0, 2 and 0, negative 2. Now, in terms of the b value, by process of elimination, this other value is going to be our b squared. So b squared is equal to 9, therefore b is equal to 3. Now, back when we were studying ellipses, we would have traveled to the right 3, and we would have put a coordinate here. That would have been another vertex, and we would have gone left 3 as well. But on a hyperbola, there are not actually points here, right and left, but rather this b value is what's going to help us draw in our asymptotes. So I like to use the method that's called the central rectangle method, or the central box. And we see we went up 2 to get to the vertex, so I'm going to make a little dotted horizontal line, one that passes through the vertex that's at 0, 2, and another one through 0, negative 2. But then if we take that b value of b equals 3, I would travel to the right 3. So rather than putting a point there or a dot there, I'm going to draw a little vertical line, and I'll go left 3 and draw a vertical line. And in doing so, if I start to connect all these horizontal and vertical lines, I've created a rectangle. This is what's called the central rectangle. So again, if you'll notice, I'll label everything here. We went to the right a distance of 3, that was my b value. We went up a distance of 2, that was my a value. And this rectangle is just an easy way for you to graph the asymptotes. So if you connect the corner of the rectangle, the center of your hyperbola, and the other corner of the rectangle, and again, a straight edge would be the best way to do this, so you're not freehanding this like I am. But if you connect those 3 points with a dotted line, you have one of your asymptotes. Likewise, the other corner, the center, and then the opposite corner of the rectangle is going to allow you to graph your second asymptote. It's just an easy way to graph the asymptotes without actually measuring. So if we take a look at my one asymptote here that has a positive slope, again, looking at our drawing, if we think about this as rise and run, from the center we went up a distance of 2, so we went up 2 and we went right a distance of 3, so the slope of this asymptote would be 2/3. Likewise then, the other asymptote should have a slope that's just the opposite of 2/3, but we can check it. From 0, 0, we went down 2 and right 3. So indeed you can see that the other asymptote has a slope of negative 2/3. Now going back to actually drawing the branches of my hyperbola, we already had determined that one vertex was at 0, 2. And now that you have your asymptotes drawn, you draw a nice smooth curve that passes through the vertex and then approaches each of the asymptotes. So this is kind of a wide hyperbola. But you'll notice again that the branches, one opens up, one opens down. That's because it was a vertical hyperbola, because the variable y was first in this case. And lastly, we want to actually write the equation for the asymptotes. So we have already concluded that the slope of the asymptote, or one of them, was 2/3. Now, remembering that lines can all be written in either slope-intercept form or point-slope, whichever you wish. But for this particular asymptote, since it's passing through 0, 0, that means our y-intercept is 0. Then the equation for the first asymptote would simply be y equals 2/3 x, since the slope is 2/3. And likewise then, the second asymptote would have equation of y equals negative 2/3 times x.